This video is a continuation of our video on rational exponents. So in the first video, you would have seen how to rewrite a radical as a rational exponent. If I had a to the m power and I was taking the nth root, remember the way you rewrite this is you have your base a, the power m goes in the numerator, and then the index n is the denominator. So when we say a rational exponent, we're talking about an exponent that's a fraction. So remember, the power always goes in the top, the index of the root goes in the denominator, and then you'll use this to help you simplify. You could also use this the opposite way. If I gave you something with a base of a, and we had an m here over n, right, you would raise it to the power and then take the nth root, or you could take the nth root and then raise it to the power. So taking a look at some examples here, we're going to use this to help us simplify. So if I said to simplify, and the first one I'll look at is 36 to the 3/2 power. Now, we're going to do this without a calculator. You should be able to do this without a calculator. So first off, what's the base here? Well, the base is 36. It's what's being raised to the power. And what's the power tell us? Well, the power of 3 says raise to the third power over the 2 in the denominator tells you to take the square root, right? The second root would be the square root. So I'm going to really write this as taking the root. It's the square root of 36, the base, and then we're going to raise to the third power. Now you could raise to the third power on the inside or the outside. Now since I know 36 is a perfect square, I'm going to keep that on the inside and put the power on the outside. You could have put the power on the 36, you'll get the same answer, just leads to larger numbers. So the power is 3, the root is 2, so I'm taking the square root of the base and then raising to the third power. The square root of 36, we know is 6, so simplifying inside, that's 6 to the third power. And then evaluating 6 to the third power. If you want, you can do it on your calculator, 6 to the third power. And we end up with 216. So 36 to the 3/2 is the same as 216 when we simplify it. Now, suppose you didn't take the root of 36 first. Instead, you did 36 to the third power first, then took the square root. In other words, you put the power on the inside of this. You'll get the same answer, but you'll get larger numbers. Just showing it here on the calculator. If I did 36 to the third power first, I got 46,656, and then I want to take the square root of that, 46,566. Oops, it's the wrong number. So 36 to the third power was 46,656, sorry. So taking the square root of 46,656, you'll see you get 216, so you get the same answer. But it's typically easier, like you could even see it when I made the mistake on the calculator, to work with the smaller numbers by taking the root if they're perfect squares and then simplifying it. Taking a look at another one here. If I said I had the 6th root of 64 to the third power. So this might be helpful to rewrite, as a base to a power first, and then we'll simplify. So, rewriting this using a rational exponent, the base here is 64. The power on that is 3 over the index of the root, which is 6. Now, once you have this, we mentioned it in the last video, 3 over 6 reduces, you should reduce it. So if that fraction reduces, I got 64 to the 3 over 6 is the same as, reducing this fraction reduces to 1/2, 1 over 2. So you have 64 to the 1/2 power. And then now we want to rewrite this as a radical. Well, it's 64 to the first power, and then the root we're taking is the square root. So we're taking the square root of 64 to the first power, which really means, just 64, right? So even the first power is itself. So if I have 1 over the root, you're just taking the root of that value, because I think the first power is just itself. So square root, the index is 2. We don't really write the 2 there. We're taking the square root of 64, which equals 8. And so the answer here would be 8. Might not be obvious from how it started, but when you have this 3 over 6, that can reduce to 1/2, makes it easier to take the root. Now you could have calculated this on your calculator, but you get very large numbers, and we're trying to avoid that. Let's take a look at this one here. If I said the 12th root of x to the third. Well, again, we can simplify this by writing it as a rational exponent. So making the exponent a fraction. We have x to, what's the power? The power will be 3 over, what's the root? The root is the 12th root. So 3 over 12. That reduces to, right, 3 over 12, they share a common factor of 3, so it reduces to x to the 1/4. And then if I wanted to write that as a root, well, it's x to the first power, and then taking the 4th root of that, the 4th root of x to the first power. We don't have to write the first power in there. And then the 4th root of x, that doesn't simplify, so we leave it alone. We'll look at one more like this. If I said I had the cube root of xy to the 9th power. Well, what's the base in this case? Well, in this case, xy is the entire base, so it's really xy in parentheses raised to the power of 9 over the root, which is 3. Remember, the root is always on the bottom, like the roots of a tree are on the bottom. And then simplifying this, 9 divided by 3, well, that's just 3, right? So I end up with xy raised to the 9 divided by 3 is just 3, or 3 over 1, but we simplify it to 3. And then simplifying this, xy, that base to the third power, when you have multiplication inside of here, you're allowed to bring that power of 3 to each piece. Remember, you're only allowed to do that if you have multiplication or division. So we have this as x to the third and y to the third, right? You bring that power to each of the bases that you see on the inside. So this becomes x to the third, y to the third. We'll talk about how to simplify these a little bit more later, but just have an understanding of how to rewrite helps a lot in simplifying rational exponents. Let's take a look at some examples that use some of the other exponent rules we've talked about in the past. If I said to evaluate or simplify, and we'll do a few of them here. The first one, if I say I had 27 to the negative 2/3 power. So now we're going to talk about exponent rules along with rational exponent rules. First thing you notice here, or should notice, is that you have a negative exponent. When you have a negative exponent on a base, remember, that means you can rewrite it as a positive exponent by writing it as 1 over that base and then make the power positive. So 1 over 27 to the 2/3 power here. And then once you've done that, now we'll rewrite this 2/3 using our rules for rational exponents. So first I use my negative exponent rule. Now that my exponents are positive, I'm going to simplify this using my my information about rational exponents and what they tell us about roots. So this is 27 as the base, right, to the power of 2, right, over 3. The over 3 is the index of the root. So it's saying take the cube root. Now I always would take that root first just so you see it, of the base, which is 27, and then I have to square it. Now I could square the 27, or I could put it on the outside of the root. Now where do you think I'll put it? Well, I'm going to put this on the outside. And the reason being is that I know 27 is a perfect cube, so this is going to be 1 over the cube root of 27 and then squared. You could put the squared on the 27, but it's easier to work with if you don't. So this gives us 1 over, evaluate the inside of this, the cube root of 27 is 3, and then that second power is still out there. And then we have 1 over 3 squared, so it's 1 over 9. And that would be the answer. Keeping in mind here, you can't rewrite this initially. Well, you could rewrite it initially, but if you use it with the negative exponent, make sure you take care of the negative exponent along the way. You can't just drop it, right? The negative exponent told you to move the base to the denominator. What if I gave you this one? If I said I have negative 32 to the negative 4/5 power. First thing to recognize here, I have a negative exponent on a base. The base is negative 32. The negative on the 32 doesn't tell you anything about directions. That's just the sign of the number. The negative in the exponent, remember, tells you to rewrite this, making this 1 over, take the base, which is negative 32, and then make the power a positive 4/5, right? So the negative in the exponent is telling you write it as 1 over, and then move it to the denominator with a positive exponent. Once we've done that, we're going to do the same thing we did in the previous example. All right, so we're going to have 1 over, what's the base? The base is negative 32. What's the root? Well, it's the fifth root of negative 32. Right, that's the base. And I'm raising it to the fourth power, right? So the root is the fifth root, the power is the fourth power. Do I want that power 4 on the inside or the outside? Well, I'm going to move it to the outside because I know 32 is a perfect fifth power. You might not know that, but it is. You can always check it on your calculator. So then this is equal to, we have 1 over the fifth root of negative 32. Well, it's an odd root of a negative, so we know it's going to stay negative. We learned that in the previous unit, or previous section. And then the fifth root of 32, well, that's a negative 2 it's going to be. And if you're not sure, just kind of a reminder, take the fifth root, you take 5, take the root of 32, and it comes out to 2. We know it's negative because it's an odd root, so an odd root of a negative stays negative. And then this negative 2, remember, is being raised to the fourth power. Don't forget that, you still have this fourth power on the outside. Once you do that, simplifying this, we end up with 1 over negative 2 to the fourth power, and negative number to an even power is going to become positive. And then 2 to the fourth would be 16, so we have 1 over 16. All right, so I do expect to see this work if you're showing it to me on a homework or a test, for example. How about this one here? If I said I had 25/9 to the negative 1/2. So again, first thing I notice, negative exponent tells me to rewrite it. Now if I have a negative exponent on a fraction, remember this rule. A negative exponent on the fraction means you take the reciprocal of that base, so 9 over 25, and then you make the power a positive 1/2. And that's the same as our negative exponent. If you wrote this as 1 over 25/9, the next thing you'd have to do is multiply by the reciprocal, but it gives you the same thing. So when you have a fraction to a negative exponent, you flip the fraction, take the reciprocal, and then make the exponent positive. Now that I have this, we can evaluate this 1/2 power. The 1/2 says to raise the first power and then take the square root. So I'm going to take the square root, now this is of the whole thing, 9 over 25, and then raise it to the first power. Well, to the first power, anything is just itself, so I'm not going to write it there. And then now we're ready to evaluate. Now, the square root of 9 over the square root of 25. They're both perfect squares. The square root of 9 gives us 3. The square root of 25 gives us 5. So the answer here would be 3/5. And we'll look at just one more like this one. If I said I had this negative 9 to the 3/2 power. So first off, do I write it as 1 over? Well, in this case, no. The exponent isn't negative. Remember, a negative base doesn't tell you to rewrite it. It's a negative exponent that does. So we don't rewrite it as anything in terms of 1 over, but we can use the power to help us here. This is really saying take the, negative 9 is the base, raise the third power, and take the square root of it. So I'm going to take the square root, right, because the 2 is the index of the root, so the square root of negative 9. Now I'm going to raise that to the third power. Now you can raise that to the third power on the inside or the outside. So, you could write it like this, or you could write it as, just the square root of negative 9 to the third power. Well, you should recognize something here. So if I was looking at the first way of writing it, the square root of negative 9, we learned in the first part of this unit that the square root of a negative is not a real number. As soon as you see that, you know it's not a real number. You can say this is not a real number. You can't evaluate that. So this is not a real number. If you didn't recognize it right away, here the negative 9 to the third power would have been a negative still, but then the square root of a negative would still be not a real number. What you don't want to do is you don't want to say the square root of a negative 9 comes out to a negative 3. Right? That'd be incorrect. Remember, we're asking what number times itself would give you a negative 9. To multiply to a negative under an even root, you can't do that with a real number. Later, we'll talk about what we call imaginary numbers, which will help us evaluate these, but for right now we can't. So make sure you watch out for that.